Welcome to Spring LIB.
The block cord Earth system is isolated, so energy is conserved as the block moves down distance x. So this means that delta K plus delta U is equal to 0. So at the top, the kinetic energy K plus the gravitational potential energy UG plus the potential energy stored in the cord or in the spring US is equal to the sum of the energies at the bottom. So that's the potential energy plus the gravitational potential energy, the kinetic plus the gravitational potential plus the potential energy stored in the cord. And this is at the bottom. And hence we get that mgx, gravitational potential energy at the top, is equal to the energy stored in the cord of a half kx squared, which is associated to Hooke's law. And hence we can find an expression for x by rearranging the above, and we get that x is simply 2mg over k. So first, let's calculate the tension T at the stretch position. So T is equal to k x, and x from above is mg over k. So this simplifies to 2 times mg. And these values are known. So that's 2 into the mass we are given is 2 kgs times g, which we know is 9.8 meters per square second. And hence we get a tension of 39.2 newtons. Next, let's calculate the length of the stretch position. So L is equal to L naught, the unstretched length, plus x. And again, we have an expression from above, so L naught, this is L naught plus x is just 2mg over k. So we can substitute our values. The unstretched length is 0.5 meters. mg we calculated, 2mg we calculated to be 39.2 newtons. And the spring constant for the cord is given as 100 newton per meter. And hence we get stretch length to be 0.892 meters. Finally, we calculate the speed of the wave on the cord. And the speed v, this is actually part C. So the speed of the wave v is equal to the square root of the tension in the cord over its mass per unit length. So we can write that as the square root of T L over m. And since these values are known, we can find the speed. So that's the square root. The tension we calculated to be 39.2 newtons. And the length we also calculated to be 0.892 meters. The mass of the cord is 5 times 10 to the minus 3 in kg. And hence we get a speed of the wave to be 83.6 meters per second.